All right, so when we look to graphing these, we want to look at some intervals, and we're going to do a little XY chart, or a little yeah. Okay, what just happened? Am I not turned on? Okay, hold on a second. I got to go to here. Programs. This isn't turned on. Help me look for smart, guys. Smart there, smart tech. Okay. I think it's tools. Well, it's my pen's not working. Hold on, I didn't want to update this. Ugh. And I'm recording this whole thing. Okay. Yeah, we'll just go up here and we'll start. See, I'm plugged in. Great. Okay. I don't really like doing it that way, but sure. Okay. So we're going to do a little XY. Ooh. Okay. So we're going to graph at intervals. And I'm gonna actually, oh my gosh, where's my eraser? Let's try this again. I only need the first quadrant. Anybody know why I need the first quadrant? They're all positive, so let's make it a little bit bigger. So we'll graph the first quadrant. Okay. So we're going to think of this as our x value and our y value. And so when x goes from 0 to 7,000, we're at 0%, correct? So this is 0. We need to think about how we're going to space all this out. All right, we've got 7,000, 28, 68, 143, 311, and over 311,000. This is actually true information. This is the tax bracket that your parents have to figure out how much taxes they owe depending on the income that they make. So between 0 and 7,000. So let's say we go up by, gosh, even if we went up by tens, that wouldn't be very much, right? So maybe we'll go up by 100. Let's space it out. Here's 100, 200, 300. We can go up here by fives. 5, 10, 15, 20, 25, 30, 35. So between 0 and 7,000, we're at 0%. And so the way we're going to show that is we're including 0, but we're going up to 7,000. So between 0 and let's say that this is 7, we're going to include 0 and go up to 7,000. And then at 7,001, we're going to go up to 15%. We're at 0%. So but when x falls between 0 and 7,000, right, we don't get charged any taxes. So you guys go out and you earn money because you have a summer job. Yes, you pay taxes, but come April, you get your money back because most of us are not earning $7,000 yet. Okay? So then we go, if you make $7,001, so if this is 7,000, this is 100,000, 200,000, 300,000 is what I'm thinking, just so that you're clear. Is that better? This is in thousands. Sorry. So when we're at a little over $7,000, we're going to, between that and 28, so maybe this is our interval, here's 28, we're going to jump up to 15%, brackets of 5, 10, 15. So here to here. Now, when we go from 28 to 68, and I guess this is spread out kind of funny, you really can't see it, but I want you to see how we're graphing in pieces. Do you all understand how we're graphing in pieces? Between 2801 and 68, we're at the 25th, 5, 10, 15, 20, 25. So from here to here, it looks like we're going to 100,000, but so we're in pieces. And this is actually another name for it. It's called a step function, because if you can see, we're stepping up at different levels. Does that make sense? All right, let's try one that's a little bit maybe clearer, a different type. Okay, so here's another type of piecewise function, and here I'm telling you the domain. So if you looked on your YouTube, this should be. It was 7A, I think. Go back on to Moodle. You don't have this one? Yeah, but I changed it like a long time ago. I don't know. If you just downloaded it today, did you have this? You don't have that here? Well, these are the ones I want you to have. So, why don't you watch me and then print out the notes that are done on Moodle? Does that sound good? All right. If you want to write some notes, you can. All right, so the domain. So, or just kind of rewrite it. I've got between 2x minus 1 and 3x plus 1. I've got a function, intervals of less than or equal to 1 and greater than 1. These domains are going to tell you how you're going to start graphing. You're going to want to do an XY chart for each one. Okay? So if I'm doing the first function, am I including 1 or not including 1? Okay, so I have to start with either the top of my domain or the bottom. In this case, it's the top of my domain because x is 1 and values less than that, correct? And we know that 2x minus 1 is in the shape of a what? A line. Okay, so we know that this is linear. So we're going to start with 1, and over here I'm putting a solid dot because I'm concluding that answer. All right, if x is 1, I'm going to get what when I plug it in? Okay, and if x is 2, I can't use this one, can I? Okay, so we're just trying to deal with the first function. So what am I going to use as another value for x? Sure, 0 or -3, or just give me two numbers, and that's going to give me -1. Would you agree? So at 1, we're at 1, and at 0, we're at -1. Now, this is a line that continues on in that direction, so we want to make sure that we have an arrow. Okay? Indicating that it kind of goes past the 2 points that I just plotted. Okay, on 2. I do my little XY chart. Again, I have to start at 1 because it's the bottom of my domain. But I don't want to include that in my graph as an actual answer, so I need to say that that's an open interval. Do you remember how you had open intervals and closed intervals when you did your line graphs on your number lines? Same idea is applying here. Because it is the bottom of that interval. Because you can't just jump up to the next integer because you're forgetting all those fractions that will work in between. Okay? So I'm going to say that x is 1, and I get what? 4, and then the next one greater than 1 could be 2 or 5 or 3 or whatever. So I'll do 2, and I'm going to get 7. All right, so at 1, we are at 4. 1, 2, 3, 4, open. And at 2, we're at 7. And so now our graph continues on in that direction. Now, what would be wrong if they were both solid dots, this one and that one? What would happen? It would not pass the vertical line test, right? And then we wouldn't have a function. Does that make sense? So the fact, does it pass the vertical line test now? Sure, because one is included and the other one is just the starting point. Yes?
Do you know not to color that one in because it's just like
greater than. Yeah, so it's just like your number line. The same rules apply as if you were graphing it on a number line. If it's greater than or less than, it's open. If it's equal to, it's solid or included. Okay? All right, so if I want to, and this was pretty much off of the YouTube, right? If I want f of negative 3, where am I going to put it into, the first or the second? We're going to put it in the first one because it's less than or equal to negative 1. And so that's going to give me negative 7 when I plug it in, right? Negative 6 minus 1. And at 6, I'm going to put it into which of mine? Second. And so I'll get 19. And at 1, which one am I going to plug it into? Why not the second? Because it's not equal to. So that means I get 1. All good? All right, well, we'll skip this one. We'll do another one. All right, you guys try this one. All right, if you've got some paper, go ahead and do this one. You have? Oh, what's going on? I need to go back and look at what happened to these notes then. Why you have different stuff than me. So this is going to be graphed in how many pieces? 3.
So for that first one, it just would equal to.
Mm-hmm. What kind of a line is that going to look like? Horizontal, right. But it'll be a ray, won't it, Megan? It'll have a starting point and continue on in a certain direction. On that middle one, what two values do you need to use to plot those points? Does that make sense that you got to use the upper and the lower bound for that middle one so that you know where you're graphing to? You don't need to use anything else beside negative 5 and 4 because that's going to tell you the highest and the lowest value for the second one. Right, so it'll be an open, but you still need to use negative 5. Remember, you still got to use those points because those are either your beginning points or your ending points. It's just, do I include those by shading it? And these little sign symbols to the side might help you kind of think, do I include it? Is it open or is it solid? And so this is the kind of work that I'm looking for also. So that's what I have. So what did you do with this one?
Okay, I don't understand if so would it be negative 5 equals 2?
So if x is negative 5, my y is 2. If x is negative 7, my y is 2. If x is negative 8, my y is 2. Does that make sense? Okay.
Oh,
Mhm.
how do you know which direction the line goes? How do you know it doesn't
Because look at which way my x's are going. My x's are going in between. Here, it's going to be only greater than 4.
Okay.
This one said less than -5. So now you know you start at -5 and it's got to go whatever direction.
Okay.
You want positive too. Oh, here, -5, -1. So this one, you've got a beginning and an end. There is no error. You following this now? Okay. How do we do? Does yours look the same? You understand which direction to write the arrows? Because that's why we start. Wherever we start, we know that that's not going to have the arrow, right? So if we look further down our XY chart, however we're plotting the remainder of those values, that's the direction we're following. Alex?
Oh, sorry. For this 5, and you stop at the 4, 8, or do you like put an arrow?
Well, look, I can only go for this. I can only go between -5 and 4. Mm-hmm.
Or if you're positive or if
Right. I'm giving you a beginning and an end in that case. Yes. A real life example of a piecewise function. You're going to spend so much money. Well, here, you know what? This one beforehand that I didn't do is an example of a piecewise function. You've got shipping costs. You will spend, if your thing costs $30, you'll spend $6.95 for shipping if you want to go standard. If you spend between 30 and 60, now it costs $8.95. It's an example of a piecewise function. Okay? If I want to go express, I'm going to spend even more, $14.95. And so this is really a real world application kind of problem. Your tax brackets, again, piecewise functions. Okay?
Why would you keep graphics?
I think people sometimes want to see a visual. They want to see visual. Where am I making the most amount of money? They'll look and see how people will send it more. Okay? Yes. Can you wait till we get through all of this? We've got a couple more. All right. So this is called the stair function. This is going to be called this type of stair step function, which we also learned to be, well, floor functions. What is going on with these notes? Not yet. Not yet. Do you have this one? Write it down then. It's a type of floor function too, yeah. This is not a greatest integer function. And here I drop my f of x here. So this is saying when x falls between what values? Sure. When x falls between which values? -4 and -3, what is my y? One, right? F of x, which is my function, my y, is equal to 1 when I'm looking between this domain. Y is equal to 2 when it falls between -3 and -2. Y is 3 if it falls between -2 and -1. Are you following this? Understand how to read this? Katie? You got a frown. I've got 3 equations. I'm going to graph it. Okay, I'm saying y is equal to 1. It's like saying y equals 1 when x goes between -4 and -3. Y equals 2 when x is between -3 and -2. Y is 3. I don't know what's wrong with this pen. If x falls between -2 and -1. I've got 3 separate equations, okay? So I'm going to space these out a little bit so you can see it. Here's -1, -2, -3. Every other is going to be 1, 1, 2, 3, 1, 2, 3, -1, -2, -3. So if x, and you're going to start with your x, okay, between -4 and -3. Between -4 and -3, my y value is what? Okay, So do I include -4? Do I include -3? So closed, open, I'm staying constant at y equals 1. Right? I'm staying constant. My y can only be 1 when it falls between -4 and 3 on the x value. Between -4 and -3, my x value is 1, my y value is 1.
Oh, okay. Okay, sorry.
Okay? No. So when y or x falls between -3 and -2, what is my y value? So solid and to open, I'm at 2. See how we're doing stairs again? We're doing steps. And between -2 and 1, what is my y value? Okay. Solid, 2, open. And why do we not have two solids always on top of each other? Yeah, it would fail the vertical line test. Okay, are we all comfortable on this one? All right, so if I ask you, is this a function? You would tell me yes. If any of these had an equal sign on both sides, you'd have to explain to me why it's not a function. Okay, Mara?
But these like wouldn't pass the vertical line.
Sure they would. Why wouldn't this pass the vertical line test? Because here it's included, but here it's not. So where is that point repeating its y value? Nowhere. Okay. All right. Is that, I think, I don't want to do that one. And that's it on this one. Okay. Let's go to the B one. I'm hoping y'all have the right B one now. I have this with B. And we're going to skip the first part and come down to here, absolute value functions. Does that look good? Okay. Okay, so do you remember this from last year? Sort of. Okay. Absolute value is a symmetrical function. It's kind of, you can think of it like a parabola. It's always got a reflection point, correct? It's going to have an axis of symmetry. So it's going to, the parent function would have a vertex at 0. This would be your axis of symmetry, and every point has a reflection point. So if you know how far to go to one side of your vertex, you can go that same distance on the other side. So the general formula is this: y equals m, absolute value, x minus your x1 plus y1, where x1, y1 is the vertex, and m is the slope. But you always want to think of this as positive, as m being positive. Now, if a negative sign exists, then we just recognize that our absolute value function opens which way? Yeah. It opens down. If m is greater than 0, then we know that our function will open up. Just as in our parabolas. Remember, if you had that negative sign sticking out in front of it, you knew that your parabola was going to open down. Same idea. Okay? You need to be careful when you're picking out your vertex. You're going to take the opposite of the x1 sign, and you're going to keep the y1 sign when you're picking up the vertex. Just as if you did it when your parabola was in vertex form. Yes? No. See, if I have negative here, I really want to take x1 as positive. And this stays. So if this is minus out here, if I have a -3, then I'm going to use -3. So you're going to take the opposite of the sign here and the same sign out here. Okay. All right. So you should have this, yes? Next one. Okay. What now? Let's talk about open. How does it open? Up or down? Okay, because of the negative. What is my slope? Okay, we're not going to include whether or not it's negative or positive. What is it? And we're going to write that as 2 over 1 because we want to have it as a fraction. And my vertex, what is my vertex as a coordinate? Well, is it 0, 3 or 0, negative 3? Right, right? You take the same sign out here. Okay? So, graphing this, 0, 3 is right here. We know that it opens down. That just tells me we're going to go down 2 and which way? Down 2 and right 1 or left 1. And that's why you don't worry so much about the sign of your slope. Okay? If I go right 1 because it's symmetrical, I have to go left 1 also to get the same shape. And so here is my absolute value with arrows at the end because they're rays.
Would the dotted line be the y-axis?
Yeah, the axis of symmetry. Yeah, you don't have to draw it, but yeah. Okay, all right. Here we go. What is my slope? 2 over 1. How does it open? What is my vertex? Yes. Are we good on this? Is it making sense? Okay. So 3, negative 6. Start with a vertex, and then we're going to go what direction? Up 2 and left 1 and right 1. So you can think about when you're wanting to figure out your x value in here, you can think about this as setting this equal to 0 and solving for x. That's how you're getting your x value. That's why the sign changes. Okay? So when we look at this next one, what do we notice as our slope? And what do we notice as our direction that it opens? And what do we notice different in this problem? The order, right? You've got to have it in that standard form of x minus x1 if you want to correctly identify your vertex. And this is not in that format. So it's 1 minus x. So that's why I said set this equal to 0 and figure out what that x is. Because we're going to think that it's negative 1, right? Because we're going to think we're going to take the opposite of 1. But really, because the x is in the wrong place, you've got to look at it as that's really going to say that x is 1. You following me? Okay. So my vertex then is at 1 comma. Good. And so then it's just the same. Uh-huh. No, because we're solving for it. It's no longer inside that absolute value. Mm-mm. No. If you're just looking at it, take the opposite of it. If you want to go through the steps, Katie, just set it equal to 0 and solve. Yeah. Why? I'm taking my x to the right to make it positive. When we solve x. I'm going to add it to the right.
Oh, you did the x.
Right. I mean, if I moved the 1, I'd have negative x equals negative 1, but that's not really solving for x. Okay, so my slope then is up 1, 2, 3 over 1, 2, 3, 4. 1, 2, 3, 4. So if we have a fraction as our slope, less than 1, do we have a wide or a narrow? Wide. So if the slope falls between 0 and 1, it's wide. And if slope is greater than 1, it is narrow. Nice piece of information to know. Okay? And your vertex is simply shifting. Okay? All good? Okay. Okay, so we're going to talk about greatest integer. Greatest integer, the word greatest integer is really confusing because we don't think about it as going up when we think about it as going down to the nearest integer. So greatest integer means you round down. Okay, so keep in mind that if you can visualize that number line in your head, rounding down means you're traveling which direction on your number line? Right or left? Left. Okay, so if I round down on 3.5, what would it round down to? Okay, which direction are you rounding, left or right? Which direction, if you round down, do you travel on the number line, left or right? Left. So how do you round -1/4 down? -1. You're going to want to think 0, but remember, we got to go left. And the nearest integer left of -1/4 is -1. Okay, -2.7, -3. You're going left, left, okay? Because it's negative. Negative, you're thinking going to the nearest integer is 2, which if I gave you 2.7, Megan is right. Think. 2.7 is here, I'm going left to 2, right? But if I'm at -2.7 and I got to go down, right, right. But you're looking at it as if it was 2.7. You got to look at the fact that it's negative. Right, okay. So 23 rounds down to, 23.1 to 23. So here you've got your greatest integer function, symbol. All right, you're rounding your answer down. You're making a floor function. That's why it's called a floor, because you're going down, not up. Okay? So making a table of your values for your domain really helps your graph. And here's how I want you to do it. We're going to do some intervals. You're going to use some negatives and some positives, 3 of each, to get a good graph. So if I'm looking at my interval between like -3, and we got to be consecutive, to -2, so everything between -3 and -2 is going to round down to what value? Right, this rounds down. So what am I really using? I'm using -3 in my function. It doesn't matter if I'm at -2.5 or -2.1. Anything that I use up until 2 rounds down to -3. So let's just use -3 and figure out what that x value or that y value is. Okay? So the greatest integer of -3 is just -3. This is not absolute value sign. It's the greatest integer. It's rounding it down. Okay? And we're going to graph this as we do this. Yeah, just this pen, because I haven't fixed the smart board, it's being stupid. So when I look at x values between -3 up until -2, not including, it's going to give me what kind of y values? -3. So between -3, I get -3. Up to -2, I get -3. So solid, open, because I'm not including -2. I'm going up until -2, because that all rounds back down to -3. I can't skip any intervals of my integers, so my next interval is going to be between -2 and -1. And what's that? Well, everything is going to round down to what? So we're really just looking at -2, right? What is the greatest integer of -2? -2. So between -2 and -1, solid here, open here, I'm at -2. Katie? Mm-hmm. And I'm just using, I'm just for safety purposes, I'm starting 3, because I go from 3 to 2, 2 to 1, 1 to 0. It gives me 3 intervals to the left, 3 intervals to the right. Yes? Okay, because I want to get some negatives and some positives, so I'm just starting at -3. You can do more, but you're just gonna have to give me more then. So next interval goes from -2 to -1 to 0, and that's going to give me what as my answer? Okay, so between -1 and 0, solid, open. Because remember, we're not using 0, so we can't include it. We're going up to 0. And then from 0 to gives me, so from 0 to 1 gives me 0. Does that make sense? Hold on. Look at this one. This one, when you do it, you're just going to take, for example, from -3 to -2, I'm going to get -9. Does that make sense? Because I'm going to take -3, plug it in here, multiply it by that 3. All I'm doing is multiplying. And on the next one, I'm going to take my interval and then add the 3.
So that would be like
Or add the 1. Yeah, that would be, well, from -3, I'd get 0, right?